Okay, now let's look at how to determine the best possible value for alpha. So in the previous video, we just simply assumed some random value arbitrarily, um, a trial value, so that we can set the model up. So now, what is the criterion based on which we will select a value for alpha? Well, obviously we want to select an alpha value that will give you the smallest smallest error measures. So in other words, it will produce the most accurate forecast given the model constraints. So one way of doing this is to simply try different values by trial and error, by just simply entering different values for alpha and then see what happens to these values, and that can be quite cumbersome. So we need a more systematic way, and then a couple of things that we can do. One is we can set up different alpha values and automatically generate the mean absolute value or few other of these measures. So we can have not just MAE, we can have MAPE and maybe MASE, all of them if you like. It really doesn't matter how many of the measures you want to check it out. Now you need to leave one row blank. I'll tell you why. And then you set up the different alpha values you want to consider. So for example, I want to consider values starting from say 0 and in increments of 0.1 and going all the way up to alpha equal to 1. Okay. Now, since we want to gather MAE and MAPE and MASE for each of these alpha values, the row that we left blank, and this is where you have to fill out the formulas. So MAE must come from that cell, MAPE must come from that cell, and MASE must come from that cell. Okay, if you have more measures that you want to gather, and you'll just simply use those cells in this as a reference in this row. Okay, so now you highlight starting from here all the way up to the end, the entire table, and then you go to data, what if analysis, data table. So now we have two different boxes here, row input cell and column input cells. Here we have only one input value because the input value is the value that changes, and here alpha is the one that changes value. You want to change alpha value from 0 all the way through 1 in increments of 0.1. So that's your changing value, and that changing value is set up as a column. So this is a column changing value or column input cell, not row. So row should be left blank. The reason why we have two is there are tables where you will have two different changing cells, alpha and beta, for example. So in that case, you will use both of them. Here there is only one, and that is arranged as a column. So it is a column input cell, and that alpha value must go into this cell B5. So enter B5 there, and that's it. Click OK. And for all the different alpha values starting from here, and you can hide this row if you like. You can highlight this row and hide it. If you don't want to show it, you can always hide it, like you can format and then you say hide rows, and it will be hidden. Okay, so and then let's format these, and you can visually see for what value of alpha MAE is minimized. MAPE must be percentages, so let's make that into percentage, and you see somewhere around here is where you get minimum MAE and MAPE, and even for that your MASE is 1, which means the best possible alpha value is still no better than a random walk model. There is one more analysis that we can do for finding the best alpha. We can also use the solver command that's available in Excel to find the best value for alpha. Okay, after having set up the model like this, then we can try to find the alpha that minimizes any one of these values. Okay, so let's say we want to minimize MAE, mean absolute error. Then you go to solver. Okay, now there are several things that you have to set up here. Our objective is to minimize. Okay, you select B23 and we want to minimize that cell value. And you want to do that by changing the value of alpha. Now, are there any restrictions or constraints? Yeah, alpha cannot be anything outside of 0 and 1. So you can add a constraint that alpha must be less than or equal to 1. And we don't need the other constraint greater than or equal to 0 because, okay, now click OK. Because we can do that by checking this, make unconstrained variables non-negative. So that means B5 cannot be negative. So it cannot be negative and it has to be less than or equal to 1. And you want to make sure that this is set to G or G nonlinear. And that's it. So with this constraint, if we click solve, Excel will figure out an alpha value for which MAE is the minimum. Okay, you can select any one of these except for, remember, ME is a biased value. So it looks at biases. So you need to use any one of the other. Okay, usually we use any one of these as your objective. Not all of them, any one of them. Okay, let's click solve. Now you need to receive this message back. Otherwise, you have not found the correct answer. Solver found a solution. All constraints and optimality conditions are satisfied. So now click OK. Then it tells you the value at which your MAE is least. So MAE is 0.99. Okay, at that point, your MASE is 0.99. It's slightly better than random walk. So the best simple exponential smoothing model is hardly better than random walk. So maybe random walk itself is a good way to approach forecasting in this particular instance, because all this additional analysis is not giving you any more accuracy.